This is Rate of Change, a podcast from Duke Engineering dedicated to the ingenious ways that engineers are solving society's toughest problems. I'm Miranda Valborth. Among all the things we take for granted, one of the most important is the toilet. Or more broadly, our access to safe, well-managed sanitation systems. When people who lack this access come into contact with water contaminated with human waste, the health effects are profound. In the early spring of 2020, I asked Brian Stoner, the director of the Duke Center for WashAid, Water, Sanitation, Hygiene, and Infectious Disease, to record a conversation about those effects and how WashAid engineers are trying to increase access to safe sanitation through solutions developed at their lab in Durham and field tested in India. Solutions including a toilet system called the Reclaimer, which treats wastewater electrochemically to render it pathogen-free and generates clean water for reuse. Then,
Sky 5 flew over Duke University, the campus of virtual ghost town.
Students won't be back on campus until further notice. Duke University President Vincent Price says this wasn't an easy decision, but they're doing it to keep everyone safe, especially after all the spring break travel.
When I finally caught up with Brian, it was April, and it was via Zoom, so our conversation sounds pretty echoey. Thanks for bearing with us. How are you doing in your team? Is everybody doing okay?
Team's doing well. I mean, well as can be expected. Being a lab-based center, it's a bit challenging when you're doing that without a lab.
Yeah. What about your team in India? I assume you've been keeping tabs on them. How are they kind of dealing with everything?
India is a challenge. It's a challenge to say, here's what the World Health Organization is telling us, and now trying to advise people to apply those procedures. For example, social distancing and hand washing is a middle-class luxury. To say wash your hands for 20 seconds to people who live in an area where, that's been water stressed for the last decade is not practical. 20 seconds is a long time. I don't know if you tried to, sing happy birthday twice while washing your hands. I mean, we do that now consciously because we're thinking about it, but that's significantly longer than most people who have access to plenty of water would do.
Yeah, as we're talking about this, it's actually, I was I was thinking about it as very distinct, from what's going on right now, but it's not. It's sanitation and hygiene as related to infectious disease. So it is all.
Thank you for making that connection. I mean, we've been getting a lot of call. I mean, there's absolutely a lot of crossover, and I think we're seeing it as well with COVID-19. I mean, what's really sad about this most recent coronavirus is it attacks those who it attacks the poor. It attacks those who lack access to health care. And a lot of what we are wrestling with on the toilet project and the global sanitation crisis, there's a huge overlap in terms of groups that are negatively impacted by the lack of safe and effective sanitation are the most vulnerable in pandemics like this, that are going to prey on areas that lack safe hygiene, sanitation, access to health care, people packed into tight spaces. So there is a huge overlap. It's actually a sad statistic in a world that has a little over 7 billion people. You have probably more than 4 billion people in the world that lack access to what we call safely managed sanitation, and that means everything from no sanitation or no safe wastewater treatment directly, as well as infrastructure that's overburdened. And this could be a waste treatment facility that was built 30 years ago, and now the city has grown by a factor of 10, and it's just overflowing. And so the water might go into a wastewater treatment facility, but then it just goes out untreated. So that's about 4.2 billion people in the world that lack access to properly managed sanitation. And the result is, you know, there are almost 500,000 diarrheal deaths every year from lack of access to safe sanitation.
Yeah, that number, every time I hear it, it does not shock me any less. It's still a staggering number. WashAid has been working on a solution called the Reclaimer, which is currently funded by the Bill and Melinda Gates Foundation as part of its Reinvent the Toilet Challenge. These toilets have to not only remove pathogens from human waste, but reclaim resources, energy, nutrients, or water.
In areas that lack access to water. So, you know, ideally we want the ability to be able to wash our hands or wash you know, surfaces that we're going to come in contact with. But in areas that are water stressed, that's a huge challenge. So if you have something like the reclaimer, or you know, more generally, the ability to treat wastewater and render it safe enough to be able to use for non-potable applications, including hand wash and other washing applications, that's a huge bonus. So the reclaimer a is a system that's designed to take uh, fecal contaminated water, and it treats that in such a way so that it's safe to discharge directly to the environment. So it meets certain international standards for discharge, and it's treated even sufficient for human contact, just non-potable use. So it's up to stopping short of being able to create drinking water from it.
I remember that when I went into your lab to meet you, that was one of the things that really stuck out to me that I remembered were the two vials on your windowsill. You know, one was the before vial was just this murky gray brown kind of sludge, and the second one, it was crystal clear. It looked like rainwater.
Yep, and that is striking. Yes, the brown muddy water looking is, I mean, that is what comes in, and what comes out is indistinguishable from your, you know, from a clean tap water. I mean, it would need to go through one more stage of treatment to remove some of the inorganic compounds and some of the salts that exist from the, you know, following the treatment process. But otherwise, to optically to the naked eye, it's indistinguishable from clean tap water.
But the end product didn't look like clean tap water in 2014, when the reclaimer was first put out into the field.
In the beginning, our technology was able to clean and disinfect the liquid that met local discharge standards, but it was still slightly brown. When you see a brown liquid and you know it came from a toilet, you know exactly what that brown liquid represents. I mean, you don't want to touch it, you don't want to smell it. So your goal is, your challenge really in converting that into something that is useful and someone would feel comfortable washing their hands with, is you have to first convince them that, you know, it's okay, but then also I think there's the challenge of um, turning it into something that looks and feels different. And so by this, and take the reclaimer as an example, The reclaimer uses the natural salts that exist in urine, and it converts them into chlorine. And so when we, if we've been to pools, pools are treated with chlorine to prevent bacteria from building up. But we know that smell. We know the smell of chlorine, and often from bleach products and cleaning products, we associate that with something that's been cleaned. We don't associate that with something that is, brown fecal contaminated water. And so part of our process, and I think one of the advantages is as we take something that's a brown smelly liquid and convert it into a clear liquid, you also end up with a residual amount of chlorine that's dissolved in that liquid, so that when someone does smell it, they already perceive it as, and genuinely, as something that's cleaner and different than what it came from.
Fun fact: Brian Stoner's father was also an engineer who worked on similar projects for use in Navy submarines. They developed a way to harvest the salts that occur naturally in urine, convert them to chlorine, and use it to treat wastewater. Brian says there's no substitute for the feedback you can gather in the field.
In the field, we've gotten so much interesting feedback from how people are using it and experiencing the system that forced us to go beyond just getting a technology that worked in the lab and met the engineering standards, but it also had to meet some of the social and cultural acceptance standards. Another just interesting anecdote is when we're testing in the lab, we don't test all the ways that we say someone can use, misuse, and abuse a system. And people get pretty creative. So cleaning solutions, standard cleaning solutions that we would use here in our labs at Duke are very different than what might be commonly available and typically used in India, for example. So there was a very aggressive acid-based solution that was being used in one village.
Brian says that every time visitors associated with the project would go to the test site, the system would break down. They were flummoxed. Eventually, they discovered that to get the site super clean, people were swamping it with hydrochloric acid, which the components just couldn't stand up to.
It just destroyed a number of the materials that we were using in our processes, and we never tested for that. We didn't know about it, so we didn't test for it. So by going out into the field, you learn a lot of vulnerabilities to your system, and we call it stress testing. and one of the challenges, I mean, you want your system to fail, meaning that you want to see how it fails and where it fails, and quickly feed that back to your engineering team so that you can design a system that becomes more robust to a broader set of use cases. If you've developed something that can only survive, if run continuously in your lab, you don't have something that is useful when you start taking it out into the communities.
Women have emerged as a really crucial stakeholder group in this feedback process. How are you incorporating, their feedback into revisions and, continuing to improve the design?
No, thank you for bringing that up. It's a sad fact that in many communities that lack safe and effective sanitation, that women and girls in particular are also disadvantaged in other ways. And so we consider women to be probably one of the more critical stakeholder groups for a number of reasons. Men, as we say, tend to go any way, anywhere, anyhow, with less constraints socially over how they use the bathroom. Women, there are a lot more constraints. So for us, it's not just being able to provide a physical need, but it's also a level of dignity and in many cases safety that's important. So in the very beginning, in 2014, we started working with a group called SEWA. It's an acronym, SEWA, pronounced for Self-Employed Women's Association. It grew out of the garment district in a state in India. But they worked with us to go into communities and establish a level of trust, especially with some of the female stakeholders, to understand what their needs are, and to be able to talk about, the safety and the dignity portion of it, as well as the menstrual hygiene element. And so a lot of groups or people or companies that try to develop sanitation solutions or toilet solutions for low-income communities neglect the need for safe disposal and replenishment of hygiene products. And that is a critical oversight.
You can learn much more about how WashAid is addressing this oversight in the next episode of Rate of Change. Thanks for listening. Please subscribe for updates from Duke Engineering. And if you learned something from this podcast, please share it with others.